Hey again, guys. So we have our second review problem on stoichiometry. This one, hopefully you realize, is a little more complicated. So it is going to involve multiple steps. The first one is going to end up being balancing the reaction. And then we are going to go through a two-step stoic problem. All right, so our first step in our problem here is going to be to balance that reaction. So remember, our first step in balancing is to write out both elements. So we have mercury and oxygen, and then how many we have on each side in the reactants and in the products. So for our reactants from mercury, we have just one, and in the products we have one. As for oxygen in the products, we have 2, and in the reactants, we have 1. So we see that oxygen is not balanced right now. We have to balance this reaction here. So we are going to multiply oxygen in the reactants by 2 in order to get those oxygens to cancel and balance and both be 2. However, hold on 1 second. So that actually makes our coefficient 2 for our mercury 2 oxide. However, we did not only affect that mercury, but also the oxygen that is tied to the mercury. Remember, it's mercury 2 oxide, not just mercury. So we have to multiply the oxygen by a coefficient of 2 as well, making 2 mercuries in our reactants. So now our mercury is unbalanced. So if we multiply our mercury in the products by 2, that balances out our reactions. We have 2 mercuries in the reactants and products and 2 in the reactants and products for oxygen as well. So our ratio is a 2 to 2 to 1. All right, so now that we have our equation balanced, the next step is to set up the stoich and just kind of figure out what parts of the problem that we need to be working on. So we have, we're trying to find how many moles of mercury 2 oxide are needed to produce that 125 grams of oxygen. So you see that we have a moles of mercury 2 oxide and grams of oxygen. So we have 2 different units, grams and moles, and 2 different elements. So we know we're going from grams of oxygen to moles of mercury 2 oxide. So if we break this down further so that we can see both our steps, we have our first step, which is going to consist of going from grams of oxygen, grams of O2, to moles of O2. After that, moles of O2, we are going to convert into moles of our mercury 2 oxide. All right, so that means we have our first step and our second step. First step is a molar conversion. Second step is a mole to mole ratio where we are pulling from our balanced chemical equation. So this is a 2-step problem. Super, super important. All right. So we are going to rewrite our equation. So that way we don't have to go back and forth a whole ton to see our problem. So give me 1 second here as I write this out. All right, so we have our equation written out. So let's go through and just set up the bare bones to our 2-step problem. We know what we're starting with. We know the unit that we are trying to find, right? We are looking for moles of mercury 2 oxide from are 125 grams of oxygen. So let's go ahead and write out what we know, that 125 grams of oxygen. And we know that unit has to drop down to the bottom and cancel, so we're going to have grams of oxygen again, and moles of oxygen on the top. Those moles of oxygen are going to drop down to the second one, leaving our unknown unit to be on the top for our final answer, to moles of that mercury 2 oxide. So from here, we know that our first step, those moles of oxygen over grams of oxygen, that's our molar conversion step. We need a molar mass for our oxygen. So 16 grams is the mass of one oxygen molecule. However, it's a diatomic, so there's always two together, meaning our molar mass of oxygen is 32 grams and 1 mole over the top, right? Because that's our molar conversion. 32 grams is always equal to 1 mole, or grams is equal to 1 mole, right? That depends on the element you have. Our second step, that's our heart of stoic step, where 1 mole comes from our ratio, right? 1 mole of oxygen to 2 moles of mercury 2 oxide. That's our mole to mole step balanced chemical equation. So if we go to the calculator and plug in 125 grams times 2 divided by 32, that gives us an answer of 7.8